Hello, dear colleagues, and welcome back to BIM and AI in Practice, your trusted resource for mastering Autodesk Revit with clarity, confidence, and practical efficiency. We're thrilled to have you join us for another session in our Revit 2025 tutorial series. In this episode, we'll continue our exploration of the Annotate tab, beginning with a discussion of filled region, drafting, and model patterns. Even if you're already confident in your Revit skills, this walkthrough will introduce practical techniques to streamline your documentation workflows, improve model precision, and foster better coordination across your AEC teams. Let's take a closer look at filled regions, a flexible, two-dimensional graphic element in Autodesk Revit. This tool is view-specific, meaning it appears only in the view where it's created. With it, you can define closed boundaries using customizable line styles and apply fill patterns to those regions. Filled regions are especially useful when developing detail views or enhancing annotation families, helping to deliver graphical clarity without introducing actual model geometry. Next, it's essential to understand the two types of fill patterns associated with filled regions: drafting and model. Drafting patterns are scale-dependent. They remain visually consistent regardless of the view's scale, making them ideal for annotations and construction documentation. For instance, a pattern characterized by horizontal lines spaced at intervals of 2 millimeters will consistently yield parallel lines separated by the same distance of 2 millimeters. Model patterns, in contrast, are scale-independent. They correspond to real-world dimensions in the building model, which makes them suitable for representing physical materials or assemblies. When used alongside detail components and annotation symbols, filled regions significantly improve the readability and precision of your construction documents. Use the Filled Region tool when you need to visually represent filled areas in detail views or when adding symbolic graphics to annotation families, without impacting the geometry of the 3D model. In addition, filled regions can serve a masking function. When views become cluttered with overlapping geometry or unnecessary annotations, a white fill can be placed in callouts or specific areas to clean up the visual output. This keeps drawings more focused and easier to read, ensuring that essential information stands out. Now that we've covered their uses, let's dive into how to create a filled region in Revit. To start, navigate to the Annotate tab. Under the Detail panel, select Filled Region. This activates Sketch mode, allowing you to define a custom 2D region with a fill pattern. Next, from the Properties drop-down menu, select a predefined type of filled region. Options typically include crosshatch, diagonal, horizontal, or solid fill patterns. Next, in the ribbon, open the Line Styles drop-down to choose the boundary style that best fits your intent. Selecting right line style is crucial for maintaining drawing clarity and adhering to BIM documentation standards. Below are several commonly used line styles and their typical applications within the AEC environment. The Beyond Line style is used to represent elements that fall below the primary view range of a plan, specifically below the bottom plane, but still within the defined view depth. For example, wall foundations are often illustrated using the Beyond style to distinguish them from elements at the main level. The Demolished Line style indicates components scheduled for removal as part of a demolition or renovation phase. This style is typically thin, dashed, and rendered in gray or halftone, allowing these elements to remain visible without drawing attention away from existing or new construction. Hidden lines are used to depict edges or objects that are not directly visible in a view, such as elements located behind walls or beneath floors. These lines are usually medium in weight and dashed, clearly signaling their obscured status without dominating the drawing. While hidden and hidden lines may appear similar at first glance, they are separate line styles. Each can be customized with distinct patterns and line weights, providing flexibility in how concealed elements are visually communicated. Wide lines are significantly thicker and darker than standard line weights. They are typically used to emphasize elements in printed or on-screen drawings, such as cut edges in plan or section views, or critical boundaries like property lines and fire-rated walls. Thin lines are narrow and light, intended for less prominent features. They are ideal for detailing minor components, including fixtures, finishes, and furniture, ensuring these elements are represented without overwhelming the overall drawing composition. Then begin sketching the region using tools found in the Draw panel. You have two primary options: draw lines manually for custom shapes and precise control, or use pick lines to trace existing geometry, such as walls, model lines, or detail components, ensuring alignment with the model's parametric elements. Finish sketching. Want to refine your sketching techniques? Our companion video covers advanced methods to help you work faster and with greater precision. After defining the sketch, click Edit Type in the Properties palette. To create a custom type, click the Duplicate button and assign a new name to the copied type. In the Type Properties dialog, locate the Foreground Fill Pattern property. Here, you can select either a drafting pattern for view-specific graphics or a model pattern, which scales with the model geometry. Once configured, click OK to apply and exit the dialog. Finally, complete the sketch by clicking OK in Edit mode. Your filled region is now active in the view, accurately representing both visual and technical design intent. On the other hand, Revit also allows you to create new fill patterns, ranging from simple, predefined types to fully customized project-specific designs. A basic fill pattern typically consists of evenly spaced lines, either parallel or orthogonal. Common examples include diagonal crosshatch, vertical siding, or brickwork patterns. These are ideal for representing generic materials or drafting symbols. To create a new fill pattern, open the Manage tab and select Additional Settings. Fill Patterns. From here, you can create a new drafting or model pattern, edit existing patterns to suit your project's graphic standards, delete patterns that are no longer needed, or export them as PAT file to standardize them across your organization. PAT file is a plain text file that defines the line-based geometry of a fill pattern. These files are especially useful for establishing office-wide standards and ensuring consistency across multiple Revit projects. Custom patterns are especially useful for model types. Examples include wood grain, stone, or Spanish tile. In Autodesk Revit 2025 and the latest release of AutoCAD, there is no native functionality that allows users to graphically create highly complex custom patterns beyond basic ones like parallel lines and crosshatches. Despite this limitation, several effective workarounds are available. You can create the desired pattern geometry within AutoCAD and then utilize external conversion tools to generate PAT file, which can be imported into Revit. Alternatively, third-party applications and plugins designed for pattern generation can be used to streamline the creation and export process. In addition, a wide range of pre-configured pattern files is available from reputable online sources, offering ready-to-use solutions for various design needs. These approaches help bridge the current gap in native software capabilities and provide practical alternatives for professionals who require custom fill patterns within their BIM workflows. Now, click New Fill Pattern in the Fill Patterns dialog. This opens the New Pattern dialog box. Next, enter a descriptive name for your new pattern. Below that, under the Type, select Basic. This is suitable for simple line-based patterns. Then under Pattern Type, choose Parallel Lines. After that, define your pattern geometry by entering values for line angle, the angle of the lines relative to the horizontal axis, line spacing 1, the distance between each line in the pattern. For drafting patterns, these values control how the pattern appears on sheets, ideal for annotations or non-scale specific graphics. For model patterns, they scale with the model itself and are typically used for materials or surface finishes in 3D views. Once your inputs are set, click OK to create the pattern. Later on, if needed, you can always return to the Fill Patterns dialog to edit or delete the pattern, or even export it as a .pat file for reuse in other projects. Once you've selected your desired fill pattern, click OK to apply the changes. Finally, select your filled region in the current view and enter Edit mode to apply the new pattern. After placing the new pattern for the filled region, exit Edit mode. You now have your own custom region. You can further refine it by selecting the filled region and accessing its type properties. This allows for additional customization, including pattern color. Adjust the color of the fill pattern to match your documentation standards or highlight specific design elements. Line weight number. Define the line thickness within the region. This setting affects how prominent the pattern appears on screen and in printed outputs. Masking parameter. Enable masking option if you want the filled region to obscure model elements behind it. This is especially useful for detail views or when isolating parts of the design. Toggle masking off if you prefer to see background geometry through the fill. These adjustments provide greater flexibility and control over the visual presentation of your documentation, ensuring your drawings are both clear and compliant with your BIM standards. Here are a few other practical tips to help you work more efficiently with filled regions in Revit. Resizing a filled region. To resize an existing filled region, simply select the region in the drawing area. Shape handles will appear at the corners and along the edges. Click and drag these handles to adjust the size as needed. This is especially helpful when aligning the filled region with nearby geometry or refining its coverage area. Checking the area of a filled region. To view the area, in the Properties palette, locate the Area Instance parameter. The area value is read-only. It cannot be scheduled or tagged in Revit, as filled regions are 2D annotation elements, not model geometry. Editing the boundary. To modify the shape or outline of a filled region, select the region and click Edit Boundary in the ribbon. Use the draw tools to revise, add, or remove lines from the boundary. Ensure that all lines form a closed loop, or Revit will prevent you from finishing the sketch. Once your edits are complete, click Finish to apply the changes to the region. When working with drafting fill patterns, it's important to understand how their orientation interacts with host elements in your Revit model. In cases where drafting patterns are applied as cut patterns, for example in walls, floors, roofs, or ceilings, you can control how the pattern is oriented relative to the host geometry. This setting directly affects the pattern's visual consistency and alignment across joined or adjacent elements. Keep in mind, this orientation setting does not apply to drafting patterns used in detailed components or filled regions. Those remain static and are always aligned to the view. Revit provides 3 orientation options when applying a drafting fill pattern to host layers: orient to view, align with element, keep readable. Align with element. The pattern follows the orientation of the host element. This approach is especially useful when working with elements that are not orthogonal or are placed at varying angles, such as angled walls or sloped roofs. Revit automatically computes a suitable origin point for the pattern based on the host geometry. How to change wall fill patterns from align with element to orient to view in Revit. Follow these steps to modify the fill pattern orientation for a wall's structure layer. First, select the wall type. In the Properties palette, click Edit Type. Second, access the wall structure. In the Type Properties dialog, click Edit next to the structure parameter. Next, edit the material for the desired layer. In the Edit Assembly dialog, click the material name for the layer you want to modify. This opens the Material browser. Then go to the Graphics tab in the Material browser. After that, under the Cut Pattern section, make sure a pattern is selected. Now, click Edit next to the pattern. Below the pattern selector, locate the Orientation drop-down and change it to Orient to View. Finally, click OK to close each dialog box and apply the changes. The pattern is aligned relative to the view, essentially to the sheet or paper space. All instances of the pattern maintain a consistent direction, which helps ensure clean transitions and perfect alignment across connected elements like walls or floors. These orientation settings play a crucial role in maintaining graphical consistency, particularly in section and plan views where cut patterns must visually communicate material intent and continuity across different construction assemblies. Now that we've covered filled regions and explored their customization and use cases in detail, let's take this a step further. In upcoming videos, we'll dive deeper into a powerful companion tool: masking regions. These view-specific elements offer a flexible way to visually control your documentation, especially when you need to obscure background elements or simplify a view for clarity. Masking regions are 2D graphic elements used to hide portions of a view without altering the actual model geometry. Think of them as visual overrides that help you fine-tune your construction documentation. They're particularly useful in scenarios like hiding or cleaning up elements in complex views, creating detail families that need to mask other components when loaded into a project, building model families from imported 2D DWG files where the background must be obscured for clarity. Unlike filled regions, masking regions automatically apply a solid white fill and can be placed on top of other elements to provide clean, controlled visibility in sheets or drafting views. We'll explore this tool in more depth in the next episode, including best practices for using masking regions in detail, components, families, and imported content workflows. Thanks for joining us for episode 12 of BIM and AI in Practice. If you found this tutorial helpful, be sure to like the video, subscribe to the channel, and click the notification bell so you never miss an update. We're here to help you level up your Revit expertise with actionable real-world insights, one episode at a time.